back to the next session of the embedded system testing. This is session 4. This is a continuation of test case design and procedures. So what we have started in the previous session. A quick recap of what we have done in the previous session. We did general testing philosophy, analyzing the requirements, what are the steps involved in that, and what are the steps that are required for general testing philosophy, and what is meant by verification, validation, and how it differs than testing. Testing is it the only definition that is used, or VNV is used, and what is the difference between testing and debugging purposes, and test planning. That is the first thing we are going to start in any of the embedded testing life cycle. So we will start with the specification plan. We will write the approaches, multiple approaches. Then we will apply the testing process covering all these aspects. Then specific to the test plan, there is an applied test process resulting in a test plan. If there are any deviations, that needs to be highlighted. That is called deviations to the test strategy. Finally, we will come up with a test plan. Test plan's goals we had discussed. It should be as per the plan and the project plan. Then purposes. Then test plan contains typical test plan contains as per the IEEE 829 1998. So this has all these elements, about 16 elements there. So also we had a definition of test strategy, what it means. Then what are the strategies, how it will be addressed in the test plan, like system test, user test, integration test, and component level test. And also we had a walkthrough of a sample test plan. So I'll just open it again so that you have a fair idea, and for the reiteration, we will introduce about the complete test lifecycle plan, what is being done. Then the references like external document, internal document, all will be referred. Then verification response. That test plan. I will just again open the test plan example. Basically, it has about 8 to 9 sections, which are all in line with what we have defined using IEEE format. It has an introduction about the test plan, applicable external and internal references for document. Also, it has an applicable customer requirements, etc., and any processes that is followed in the test life cycle. And verification responsibility, verification methods, activities, what is the environment, and traceability to compliance mapping in terms of the process we had gone through. Additional considerations, anything specific we need to have, that also we have to consider. And then standard checklist and any guidelines that's part of the testing is concerned should be used. So introduction will have purpose, responsibilities, change control, compliance, abbreviations, and the external, internal, applicable documents will have to be highlighted. The next section, verification responsibility, what is the organization structure, who is going to control what aspects of the test, all this will be highlighted. And of course, any industrial embedded testing has to be following some sort of a standard. Like in aerospace, they follow DO NFV, which calls for independence. That means here independence means the testing team has to be different than the developer team or the development team. So in that way, independence has to be maintained. Why this is needed is to make sure that the test team is not aware of some of the implementation details or some of the philosophical layout of how it is being done, or they should not be biased. So make it that independency. It is always suggested, or it is mandated to use an independent team for verification. Verification methods, testing method, review method, analysis method. Verification activities. What are the verification activities? Planning of specification, verification of system requirements, verification of high-level requirements, verification of outputs of the integration, the verification of the overall testing output, the outcome, that is, and verification environment, test codes, qualification, and test harness. Of course, we are going to detail out each aspect of this in the next session or next slide. And we need to maintain a traceability of what is being covered in testing. Additional considerations with any partitioning used, compiler, any commercial or official tools are used, and that needs to be highlighted. And from the process perspective and the guidelines perspective, we need to mention the standard, checklist, and the guidelines. Something like a testing guideline, testing standard, how it should be. Those are all will be used. Of course, during the review, the same thing needs to be go through in order to maintain the review. So after we go through the test plan, we know that there are a lot of elements that are part of the test plan. So as part of the first step, what we are going to do after the test plan is approved and in place. We are going to start with the test cases, test case design, test case procedure. So this outcome of this test case design procedure is nothing but development of test cases for each of the requirements or the group of the requirements or the specification that is provided to the testing team. And to map with that test cases, we are going to come up with a test procedure. As I said in earlier session, test cases are theoretical steps of the groups or the logical groups of the requirements or the specification. Test procedures are the practical steps, how it should be done. Test cases will tell what to do. Test procedures will tell how to do it. Test cases are theoretical steps. Test procedures are practical steps in terms of covering all the test cases. Okay, so what is test specification? So the specification defines what to test. Test specification is part of the test layer, that is nothing but some of the testing elements or a process. Basic building blocks of test specifications are test cases. Test specification will have an instruction, how to use the state and all that. Test specification will have requirements highlighted. Test specification will result in reporting how much is covered, how much is placed, etc. So today we will go through an example of test specification. Before that, I will reiterate the test case design steps. We need to analyze the requirements. Here, the requirements could be any of the embedded system product specification or software requirement that needs to be analyzed, that needs to be understood from the system perspective. Then we have requirement categorization. Here requirements categorization in the sense we need to categorize the different sort of requirements, like it could be timing requirement, or it could be performance requirement, or it could be uh, uh, any of the functional requirements, etc. So these are all will be categorized from the requirements perspective. Why we need to categorize is that this will ease out the tester's job in terms of his understanding. Suppose, because why I'm telling you, suppose we have a team of 4. Suppose we can divide the team structure in such a way that one person can concentrate on the timing aspect. One person can look into some of the functional requirements. One person can look into performance requirements. One person can look into timing, any other memory related or anything, etc. Again, we can divide that. In terms of categorization and aggregation, it is a good practice that we have a requirements categorization. Okay, so once we have the requirements categorized after understanding the or analyzing the requirement, we are going to identify test cases. So as I said earlier, test cases will have test identifier, then test conditions, that is for the identifiers we have the different conditions how that the test cases will be used. Then we have test inputs. Then test inputs are nothing but the different test values that will be fed to the system for that particular requirement. Then we will write the test output. So what is the output expected of the particular test case? For doing that, there are test conditions which will be applied for executing the test. That is the next step. Next one is the test case equivalence criteria. Once we have this set of activity done for a group of requirements or a specification document, we are good for writing the test case. That means we have an understanding of how the test case should be. That's how we have started with the test case design. Once we have that, then we are going to apply the criteria. Here criteria means I will explain that in particular how it is getting done. Suppose one test requirement, one requirement is supposed to take few values, or the requirement says that it can take 1 to 10. Let's say example 1 to 10 inputs. How I going to test it? So definitely the system is supposed to work taking the value 1, taking the value 10, taking the value anything between 1 to 10. So we have to design in such a way that all these values have to be excised. It doesn't mean that all the values in incremental manner should be excised, but the test case design should use a criteria such a way that it will excise enough for the system to pass through all this. That means if I have suppose 1 to 10, then I will do a equivalence class in terms of boundary. Here boundary is, we know that requirement can take 1, the requirement can take 10. So the lower side is 1, the higher side is 10. And a moderate value also will consider, that is an intermediate value. That is called equivalence we are going to do. So 10 we can do a equivalence of 2, 10 by 2 is 5. So we will select values as 1, 5, 10. This will be my equivalence criteria for a normal range of test data. Then coming to there is one category. The next category of test cases design in terms of test case inputs is that robust. That means it could be an outside the normal or abnormal input, etc. For example, the requirement says that a system can take a value of 1 to 10. So we know that systems should work for 1 to 10. Also, we should make sure that the system will not work, or the system is not going to take the values anything outside 1 to 10. So what will be our inputs for this condition? It will be outside this. That is nothing but the robust range or the abnormal range. The input value could be a 0, input value could be a -1, input value could be 11, etc. So these are something like outside the normal range or the abnormal input or the robust input. There are chances that the system may not accept. You need to understand this. Why? Because suppose a knob, electric knob for a fan will have 0 to 10 as a preset value. So how do I feed 0? How do I feed -1? How do I feed 11? Is the question. So again, I am reiterating that this again depends on the test harness, how we are going to develop it. I need to figure out a way of doing that or providing the input. If that is not possible, then you need to justify using different means. Here there could be a manual go through of that, or I am doing a simulated into the particular piece of software which is responsible for taking the values from 0 to 10, etc. So in that way I am going to design it. So all this will be part of the test case design. So what are the test cases? What are the inputs? What is the condition? And what is the expected value for each of these categorized tests? Okay. So now we know that we have done the requirements analysis, test cases identified, test conditions, so we know the test inputs we have defined. So all this will be the next set of exercise we have done. Next, once we have done various test cases, for example, for the example which I told 1 to 10, I could end up with writing some maybe 15 test cases. Similarly, requirement 2 will have a different sort of a functionality. That may be having test cases of maybe 20, 50, 100. It depends on the particular requirement. What I am going to do now, I am going to group it. So grouping is again based on the functionality or the timing and performance, etc. It need not be purely based on the requirement. It is also based on the execution criteria. Suppose I am going to execute one set of requirements, and the next set of requirements also could go through the same execution path. I can group it. So there is a chance that I can group multiple set of test cases for multiple requirements in this grouping activity. So grouping is only an very important activity where we are going to group the test cases such a way that it is meaningful and it is practically executable, and the segregation and the report generation will be easier. So that is the intention of grouping the test cases. Of course, sometimes what will happen is grouping the test cases may not be enough. So what we have to do is we have to consider some of these cases as a special categorization. We may have to ungroup it, or we may have to categorize as a independent test case or a lone test case. It doesn't need to be fall as an independent. It doesn't need to be fall as a grouped test case. It can be a special category test case. Once you have all this, then we are going to have a basic demarcation of the entire test in terms of functional and non-functional failures. We know what is functional. All the user driven or market driven or the product driven requirements are all called as functional, and The non-functional requirements are something like performance related or timing related, or what is the throughput, and how much it can tolerate in terms of the current or voltage, or it could be size of the memory, etc. So these are some of the non-functional requirements. All this will be part of the complete test case design. So this needs to be thoroughly done as well. This is the teamwork. This has to be done with the help of the team. As I said, there is going to be a structure, test organization who will, I think I have explained in the test plan, I think about that. Which will have the structure defined for test case development. So as per that, we are going to develop the test case design. We will consider an example of test case design. I think I will visit this page probably after going through a test spec. Test spec is nothing but test specification. It will have a test case identified. Okay, in that example, we are going to see unique name or a title of the test case will be there. There is a unique identifier for each of the test case, a description of the test case, the preconditions or the prerequisites that is required for the test case. Preconditions are something like which has to be mandatorily followed for doing the test, that particular test. That means it's a predefined condition for that test. Then we'll have a steps which are all test case steps. Then we'll have the expected result for this particular test case after giving the specific inputs. Okay, after this we'll have an understanding of test procedures. Okay, now we'll go through a test specification example. I hope I'll be able to share. Okay, software test case development. So I name it as STC, which will have a released version of 1.0 and the product name and its variant. It is something like embedded instrument, variant 1, variant 2, etc. will be named. Then we have the template as you can see. We'll have the project of product name, end customer name, who are the stakeholders, what is the test case development. We have a review history, and we have the POC as the test case identification. Then there is a test group. As I said, the test cases need to be identified first. Then for all the requirements, once we have identified the test cases, we are going to group them based on the grouping criteria. And as I said, there is a end document highlight portion which will highlight the preconditions. Preconditions are nothing but the conditions that must be available for executing that particular. Okay, how test cases are identified for each of the requirements. Whatever I am showing is an example of a typical test case document. It may not be this way all the time, but mostly this covers minimally the aspects of embedded system test case. This is an example. So what we will do is we will first specify the requirement with its ID, the product name, what are the SRD. SRD is the software requirement document. Each of the requirement will highlight. Then so what is the functionality of that requirement? We are going to test it in this particular test. Then any interface requirements we are going to test it. Here interface requirements, basically a software requirements document. Of course, I'm going to give an example of how SRE looks like. Basically, it will have a couple of parts. One part will be highlighting the basic operational or functional requirements. The other part will be surrounding this operational requirement. Surrounding means it could be an input to this requirement, or it could be an output to this requirement, or a linking requirement, or an interface requirement. Interface could be interface with the primary requirement. Suppose the requirement says that some value, based on some value, some action will be taken care. So this value, how it is going to come, is what is going to be attached with the interface requirement. So interface requirements will specify about the interfaces required for the particular set of requirements. Functional requirements will highlight the functions or the operations. All this will be listed as part of the test case identification, because this test case identifier, whatever you are seeing in the table, will cover up all these requirements. This test case list. Here is the format of test case design. It has a test case ID, it has an input, it has conditions, and finally we have, as I said, each test case will be identified with a unique ID. It could be ending with a TC01 or TD001, whatever it is. Then for that particular test, so what is the input I have to feed to execute the test. Then once I provide the input, in the first one you see as a first set of inputs. Here we are going to specify the inputs that will be used or applied. Then the conditions. Once we provide the input, what I have to do? Should I power on something, or should I move the product, or should I switch on something, etc. So all these things will be specified here. The conditions that are aligned with this input will be mentioned here. That basically triggers the test. Of course, at the end of the result, at the end of the test, based on this condition, so what is our output that can be tested? That is highlighted here under expected. Mention the expected output based on the triggered criteria. So likewise, we are going to have different test cases. It could be 1, 2, 3, 10, as I said. For the example, requirement identification starts with a requirement. The requirement could be a functional requirement, identifying all the functionalities of the particular requirement, and for each of the requirement or any of the requirement, it could have an interface requirement. As I said, interface requirement is surrounding the functional requirement, that you specify the interfaces that are required to satisfy the primary requirement. The interfaces could be any input value or any output value, etc. So all these have to be covered in terms of addressing a functionality or a functional requirement. So the test case framework is something like there are 4 columns. One is a test ID. So this will identify test case. As you see, the product name followed by its variant. Then you have a TC. Then we have a unique number. So we can we want, but that should be all coming under this set of functional requirements. And that specific test case has inputs. So what are the inputs to execute that test? Specify the inputs that will be applied. This could be first set of inputs for this test case 1. And the condition, this condition on the input that triggers the test. If conditions specify, what is the condition that I need to do it to really accept the first set of values. For these conditions, once I execute, what is the output I can expect? The output could be any value or any monitoring output or anything it could. So all this has to be mentioned in the last column. So this will complete the one test case. Similarly, we will have test case 2, test case 3, etc. Test case 2 will have a second set of inputs and it will have its own unique second set of conditions. It will have second set of expected results. So let's develop a test case. I repeat again. So each test case will be unique by itself. It will have an input. It will have that will pick up that input, and it will have an expected result after that conditions have been executed. So all these steps have to be formatted in this table. For the requirement, this test cases have to be listed on. So this requirement, what I have highlighted here, is nothing but for one requirement. Likewise, I can have multiple requirements. So likewise, I am going to create different test cases. So this document will end up with all the test cases identified in the first section. That is test case identification per requirement. That is, each requirement will have identified multiple test cases. Okay. Now we know that there are number of test cases. CC 001 to 002, 10, 20, 30, whatever it is. Once I have identified, as I said in my earlier slide, we need to group it. The grouping is taken care in the next section. So this grouping will have its own identification, TG, test group. You can tell that the functionality. As I said, the grouping is really based on the group of requirements or the functionality or some criteria which will help a particular tester to carry on its test. That's why we name it as functional name of that group. So I put an example, more entry is one group. Issue is the first issue, second issue, etc. We can have it or we can, depends on the configuration we want to have in the document. Okay, so in this group, what are the parents I'm going to take care? So I have requirement test case ID as 1, test case as 6. So these two parents I'm going to cover. Parent is here nothing but pointing to the test case number. So these test cases are grouped basically. Then I'm going to mention the owner who is responsible for doing this grouping. Then we have what sort of a grouping it is. Is it what sort of a test cases I'm going to cover in this group? As I said, it could be normal range, it could be robustness, it could be review, or it could be manual, whatever it is. You can mention the type, particular type which is applied for this test case, or sorry, this test group. Then we are going to have a reference. The reference could be anything within the requirement. It may not be enough to just write down the test case and test grouping. So we need to probably refer some of the other supportive documents like tolerances or constants or any of the system level information. That is very much important. That is for understanding purpose that we can refer it here. The next section is next highlighter is the precondition. As I said, the preconditions could have to be in place for executing this particular group. We will what is precondition? I'll just have a look into it. For example, appendix A point to a precondition set 1. Similarly, we can have multiple preconditions. Here we have listed as 2 preconditions. So I am going to use first precondition. That is, precondition 1 is used for developing this test group or grouping different test cases, test case 1 and 6, and these preconditions have to be in place before or for taking of the test case, this particular test group. Precondition 1, what will be the precondition 1? So the preconditions could be something like we need to power on the eminent product unit and set some of the values, or below settings have to be performed. Some of the default conditions or the specific conditions like potentiometer values turning into some microfarad, or resistance putting to some value, or some of the discretes should be enabled, or a power has to be 3 volts, 5 volts. All this can be part of the precondition. So that's what list all the preconditions which minimally need to be set before test initiation. And that is about precondition. And okay, so we will come back to this section again later. Similarly, I am going to have a next group in terms of XXX, YYY, test group 0002. So what it does is it will identify the next test group. I'm just going to write down all this so that it is something like a development which we can understand. Okay, some product name and what are the function names usual voltage. So this functional grouping is on the voltage related. The next one will be test cases. What are the test cases? I am going to cover. I am going to cover test case 45 and 46, and it could be any number 10, 4, etc. Once I have the test case parents identified, I am going to name the one. Here it will be a second owner of this particular test. So what type of a test it is? Let me mention for voltage related as robustness. So what I am going to do in this test is robustness. I am going to cover performance. Some voltage test will have to be done with certain constraints. I am going to refer voltage chart. Typically, there will be a tolerance or constant table or those sort of a requirement that will be used. Okay. Next one is the precondition. As I said, the preconditions are nothing but the minimal set of values or default conditions that needs to be in place. The preconditions I am going to have here is that apply the voltage 3.3 for at least 5 seconds. So what it means is that for doing this test or before start of the test, I must make sure that this voltage is used for 5 seconds. That is what the precondition is. So that is about the precondition. Okay. So next one is the inputs. The inputs for this test group. As a group, we know that what it is capable of, what are test cases it will cover. So we need to highlight that those inputs. That can be steps. That is a combination of all the steps in terms of this test group will be highlighted here. Next, once I have highlighted the inputs, I am going to describe it, and I am going to provide an expected result combined. So basically, this will have again the test cases what we have identified similar to this, but in the grouping, what I have done is I have highlighted multiple requirements with a flow of expected results, so that I can continue from test case 1 to the 10 or 20, whatever the grouping that I have done. So that is the idea behind having these two steps, identifying the common set of inputs and describing the conditions and the expected results. So before the end of this test group, there is a test bench that needs to be highlighted. I will later tell you what is a test bench. Basically, the test bench is a test setup, or the test setup on which I am going to execute this test group. A test bench could be automated test or a manual test or a test with an open box, etc. So all that will be mentioned here in terms of test group. Same thing we are going to have it for all the groups. After the precondition, this will happen. So likewise it is going to continue all the grouping of the complete requirements. So that is about the requirement grouping. So first section we will identify the test cases, all the test cases for each of the requirements. Then once we have identified all the test cases, we are going to group them. The grouping strategy. Once all the grouping is done, we make sure that all the test cases have been covered in our group. With that, the test case development is complete. Of course, in the end, we have appendix. Appendix, either we can use any pointer to any of the documents in this, or we can use appendix for highlighting the precondition. Also, we have highlighted as an example the appendix. Some of the test scenarios, list of static analysis. As I said, the test bench that I am going to use could be a code walkthrough. So it could be using a static analysis method. So I am going to list out what are the tests that will be taken care as a static analysis. So what are the tests which are categorized under operational or functional requirements. So what are the tests or test groups which have been taken as a non-functional requirement. So this will provide me a list of complete set of tests. So this is something like a coverage matrix, I can say. In cover this under a separate section. Here I have to cover under appendix. It is up to you how you want to design it. Test matrix or test test coverage matrix or whatever you want to name it. So this will highlight all the tests and the grouping how it is done, and I am going to list it out. This will be a complete test case development or test case design document. Please post me any questions if you want to have. You can touch base on each of these specific sections with an example. Of course, I am going to provide you this template, and I am also going to provide you a couple of exercises. So you can exercise this, and you will have a clear idea about it. So that is about an example of test case how it is going to be developed. So all these are part of the test case design. I have put some example, something like how I'm going to design test case. We have gone through a test specification. We have gone through the test specification example with all these aspects in terms of test case design. One example I have put here, considering a telephone instrument, the instrument which we want to test it, which is having an embedded software, can be called as a test object. The tester could test different things about the instrument. For example, telephone should allow user to talk to other phone. The telephone will have features like redial, flash, conference call, or any other calls adding to that available or not. If it is available, can they be used as per documented, whether they have documented enough to have this. The one thing is that the product as such is complete only when it is appropriately developed. Here, developed means the product should have a complete user acceptance. The user acceptance could highlight a manual or document how it should be used. That is a theoretical part, along with what it is capable of doing for its operation or its usage. Similarly, how we are going to instrument, how we are going to use that instrument, how long we can use it, how much capacity the instrument has to store call history, dial number, call duration, etc. So all this will be part of the requirement analysis. I would say understanding of the system. To have this above items in place, the tester should have an information about what it is expected from the instrument. That means the instrument has to be understood by the tester. So these aspects are to be considered for analyzing the telephone instrument. Here I have put as an example. That means the tester should have an understanding of the product, what is testing thoroughly. So this is what basically the need of the tester, without which he cannot develop the test case. Okay, so we have gone through this with an example. So it will have an unique name or title, unique identification of the test case, its description, preconditions for prerequisites. So what are the steps, that means the conditions that will be done. And in the last column, we are told that the expected results have to be provided. So some of the suggestions for mentioning the test case are as per below. Short unique names will enhance the reliability of the specification and test reports. Unique identification of the test case. All test cases should follow an identical defined format. As I said, it should be in a definite format. The ID must be permanent. Adding or removing the test cases shall not change the ID. So this is very important point here. Suppose I have say test case 356 as the last test case. What will happen is during a review, suppose only test case, so maybe something like 150th test case has some problem, or we thought that is not possible to execute. So what we will do is we are going to invalidate that, or we are going to delete it. By doing that, the numbers could impact. So still, what it is suggested is that we should not hamper the number that is there in here, what is being configured. I have this as a first version completely. In the next version, I should retain the same thing except the one which I don't want, or except the one which I have modified. So that way we should have a readability and a control of it, because there are multiple stakeholders which will be depending on who will be depending on different test cases, and they would have already gone ahead by developing test procedures and all that. It is very much impractical to change the test numbers everywhere. So the suggestion is, if you want to delete, just go ahead and delete. Don't alter any number. And suppose you want to insert a new number. Suppose a new test I have introduced, I'm going to do as a 57 as a last. So this is a suggested way. The same thing is told here. It should be permanent. The numbers should not alter again and again. The description will have a brief description explaining functionality that test case covers. Preconditions, as I said, exact description required system state or some of the conditions that needs to be done before the execution. Then the steps. Last one is the expected result. So this is about the test case design. Okay. Next we will go to test procedure. We know that test cases we have developed. It will tell what should be done for covering the requirement. What should be done to test a particular requirement. It covers all the aspects of the theory in terms of how test is designed. So what is the input? What can be expected? To achieve that expected result, or to achieve that triggering of the test for that particular test case, we need to have a practicality of that test in terms of test conditions or the different values, etc. So all that will be part of the test procedure. So this will be something like it defines how to test. It's a stepwise actions on how a test case or group of test cases can be run or executed. So basically, emphasis is on how to run the test case to produce the expected result. Very much important. For me, it's very much important how to run. We know that for test case, it's what to test. So test procedure has to be 100% mapped into the test case, because we have developed a number of test cases. All those test cases have to be one or the other way should be executed. So how we are going to execute is what this test procedure is going to highlight. Test procedure's job is to tell the user or the tester that how he is going to perform the test. So we will go through the test procedure as an example. We will be able to see this. This is that test procedure template with a few examples here. This is a bit elaborate than test cases. This document is huge. You will understand why it is important and why it is bigger than the test case. Test cases are something like a design. Test procedures are something like making the design work. So obviously, making the design work has to be more elaborated and more procedural oriented. So the template starting headers and all that we have conflicts as per the standard. The first few pages will be same as test cases and the test plan. We have a about 2 to 3 sections. So okay. Test introduction, test environment, test procedures definition. And we have appendices. Okay. So in the first section we are going to introduce about the test procedure. This document defines the test procedure for embedded software product. Its purpose is the definition of the test procedures based on test case design and description. As I said, test case is the primary input for developing this test procedure. The objective is to cover 100% test cases or the test case scenario. How the procedures are organized. So the organization of the test procedure is something like this. It has a preclude, it has VVID, it has a postclude for the ending node with a VVID and VVID. It is up to the test case designer or the organization or the follower how he is going to write it. But in general, it is a good practice if you have writing to the VVID will have a test procedure ID, beginner, the name of the function which is under test, and which test case we are going to cover. Okay, so one issue is there here. It should be test group, because we know that I will go through that test case example. So easier to match. So test cases we have covered here. In the next section we have told about the test group. The same thing we will map it. So example is test group 1. Which group I am going to cover in this test group. So it should be mapping to the test group. Okay, the owner is a person who created or modified the scenario for the last time. That means the person who has worked last time. It is made of first data, first name, first field, surname, each blah blah blah, whatever you want to have some of this time. And again, I am telling you, this independency has to be maintained in terms of the testing. The testing group has to be independent than development team. In a certain stringent organization, like aerospace or safety critical projects, I have seen even the test procedure writer or test executor or the reviewers are totally independent. Typically, the one who develops the test scenario or test cases will not be executing, or he will be executing the other person's test cases. So we will do a mix and match sort of a thing. So in that way, independency is good. So this is for the cause of independency and bringing up the quality, transparency, and thorough understanding of the system. So that is why to have an independent test doing all the mix and match of the different activity. Next one is the test setup. As I said, the test bench, what I am going to use it is what this will identify. Next is the test type, same as what we have mentioned here, normal range, robust, review, whatever. You may ask why we have repeated here some of these fields. It is because every time whoever does the execution or whoever develops the scripts or the test sample did not have to go through the test group or test case immediately. He has a fair idea about the test group or test case group, so he is going to develop the tests and the scripts actually. So better he knows all those inputs in these two steps, the setup as well as the type, and the same set of preconditions can be used here. One of the other important thing is that the preconditions can be more elaborated or detailed. As I said, in the test case development or design, we might not have come up with a complete practical knowledge. What we'll do is it's the likely setup that is going to be used, or a overview of the setup that is going to be used. Whereas in these steps, we are going to be exactly mentioning what is that we need for doing the execution of this particular procedure. Once all this base work is done, these steps, we are going to have the test flow. This basically the practical steps, the sequences or the action that needs to be performed on the target or on the system to execute this particular test group. Test procedure. We'll end with a node. So this is how the test procedure is organized. Likewise, I can have multiple test procedures. The next one is the applicable documents which I am going to use. As I said, test plan of verification plan test case document and customer supply document, standard templates, etc. So all these references which are useful or which are the basic inputs for developing the test case will have to be highlighted in the applicable documents. And any other reference documents like IEEE, anything like DO standards. Just we have all observations. Now I will say that test procedure is organized this way. This three sections, a very important section that is where this document has to be a separate or unique one. What I say in several places or application testing, I have seen or I have heard that there will not be any separate test procedure document. What they do is they develop the test case, and in the same document they are going to mention this is what I am going to do, this is what I am going to execute, and this is what I am going to test. That way they will cover it. But in that way the control may not be 100%. So in many cases or many domains, it is mandatory that they will have a separate test procedure. In that again, these three steps are very important. Those three steps have to be specific to detailed information, or they will be pointing to a separate section. The section could be something like this in the below. So what is the environment we are going to use for doing this test procedure or executing this test procedure? So test environment will have environment identification. The environment, as I said, the test embedded test environment or the setup, how it can be used or how it can be identified for executing the test. The environment basically will have two types. One is automated testing, other one is the manual testing or debug mode testing. We know automated testing, we use less human intervention. We use batch execution sort of thing. We use a APT based application where we have a black box sort of an approach where we will have a scripts running all the time, and we will monitor the output or measure the output from the end target system. The second type of environment we could have is the manual mode of testing. This will have the hardware opened or the hardware hooked, a debugger or any of the measuring equipments hooked inside the target board or specific pins. The measuring instruments could be oscilloscope, digital multimeter, or any of the frequency generators, anything it could be. Basically, we categorize test environment as two types: automation testing and manual testing. As part of the environment, we will identify tools. What are the hardware tools I need to have an environment? I will think probably in the next session I will explain few slides about test bench or setup, or in particular a target, how it is going to be used in the environment in terms of emulation, simulation, or monitoring, etc. To do all that, we need to have identified the environment. The environment will have tools. The tools could be hardware and software tools. The hardware tools are something like the target board, and the target board having programmed embedded software, interface board for providing a discrete or analog, special hardware if anything needed, an emulator or emulator with that evaluation board from TI. It could be an adapter for RS232, CAN, Ethernet, any other separate setups needed. Of course, we need a power supply, we need a DMM, digital multimeter. I think I'm going to have a slide for jargons, embedded term, which are used in embedded systems. There is a separate slide I have prepared. I think I'm going to add all this one by one, so that just we can have a recap of all those words. Those words have to be in mind for an embedded system or embedded system cluster. Digital oscilloscope, PC, and for software tools we use target connected system called PC based application or automatic software application. Software tools could be an integrated development environment, which is a tool which connects to the target board, primarily with the processor, which will help you to program for development perspective and debug and test from the tester perspective. And to program a new images, new software, we use a Flash programmer or any GUI. Sometimes a GUI is also used. GUI or HMI. Plastic program. Any software which interfaces the embedded product. Any tools for monitoring the Ethernet, monitoring the CAN network, anything it could be. So these are specific for software tools. Next, once we have this hardware and software tools identified, how are we going to have the environment up? How are we going to have the test setup made available for the test procedure execution? So setup will have a connection, setup will have a power supply, setup will have a IO, etc. Probably we can touch base an example the next session. Similarly, on a host, we can have application setup. So here we have highlighted embedded or the target based setup procedure. Here we have highlighted application setup procedure. Application setup procedure should be connecting the USB to the host with a CAN card or adapter. This is an example, basically, or JTAG cable, emulator connected to the target board, and etc. Okay. So the other important aspect of the embedded software testing is we may have to build as per the documented development process the embedded product. So that we need to have a build instruction available in the procedural document. Software build. I will tell you what is software build. This is basically a embedded software program which is going to reside inside the embedded target. So to do that, we will have the source code, or we will have the object file compiled, linked, and which will be programmed eventually on the target system. To program it, we need to develop the image. It is called as an image. The image is nothing but a raw file, raw binary file, or hex file, or X record. There are different formats that are used, specifically based on the target board and the processor. So the build instructions will be something like use the PCS. PCS is nothing but Code Composer Studio. As I said, this is an IDE which will be used for programming or developing the code, compiling, linking, and generating the executable. First, we will do that. Then we will load that executable using an HMI. HMI will be used as a utility to program to connect first the target system and program the image. That image was built in the previous step. Then we will download that. Then we will have a debug creation in terms of verification or debugging. Sometimes we may have to have additional projects imported, so that will be part of the next step. Then how we can download those additional imported projects. So these are some of the steps involved for building the embedded software. So this will be part of the test procedure section. One of the sections should highlight this. Next will be test execution. How am I going to execute the test? So for executing tests, it could be, as I said, this could be using PV-based applications or any of the scripts or any of the automation that we have done in the host machine. So the scripts are created from the test procedure document, that is this document, using a tool. So this is just an example I have here. So basically, the test procedure, the steps are used as a test step, and one example is that all those steps will be mentioned in an Excel sheet. Excel sheet will have the same table as I highlighted in the previous test case development. So I will again show you how it looks like, and that Excel sheet will be used as an input document sometimes, with certain columns highlighting the values and certain columns highlighting those values as inputs or outputs, and certain additional columns having the expected values. This will be used as an input, and the script will take this Excel sheet as an input and generate the script, generate the triggering values on the target, and it will execute. So the script basically takes the inputs from the test procedure document. The test procedure document can be an Excel sheet, and it triggers the values as specified in the Excel sheet, and it produces the results, and it compares the results also as per the expected results that is part of the Excel sheet, and it generates a pass failure. And the tool generates the relevant test scripts files are also known as test sequences. It's also called as test sequence. Then this will be opened in a Windows application for execution. See, basically this is an example. It will not be this way. There are different methods that they have used. There could be an XML based test generation, or Excel sheet based test generation, or VB application, whatever it is. VB script, Python, Perl. It is up to the test development or environment based on their feasibility, how they want to have a test execution done for the set of test procedures. The next one is automation testing using PC based application software. This is basically the application which will be used for developing the post based tool. So I have put an example typically how it is been done. The PC based automated test software is developed using either a VC test or Visual Basic application. This application software provides a GUI for user to develop, edit, delete, and execute the test scripts. As I said, the test scripts are nothing but a Python or Perl based scripts. Those scripts can be hooked or edited or executed from this PC based application, and a test engine to sequence or execute the test cases will be part of the PC based application. This software also has an ability to run test sequence automatically. That means we can have a batch to execute multiple scripts, etc. So that testing will be automated. The embedded software is updated to add the test functionality without affecting the software normal functionality, which provides interface between the target software and the PC based application software. So here what it means is we have developed the PC based application, and there should be a means for this guy to connect with the target. So this connection could be anything. It could be CAN based, or it could be RS positive, or any of the communications we can use it. So basically the interface has to be there so that the PC, the application based in the PC can be used in order to communicate with the target. So in order to communicate with the PC, there has to be an equal or corresponding responses or the reactive updates at the target system. So there has to be something that is called a test code or test hook. Basically, that will have a piece of code, part of the embedded software, which will interact with the PC based application. So that is what is being told here. The embedded software is updated. That is the basic core system within the embedded target will have an additional test functionality. It is mostly it is called as a test code. So without affecting the software normal functionality, we have to be careful in terms of test code, which should not impact by itself just for it is there inside the embedded software. So which provides an interface between the target software and the PC based application. We may take up an example at a next stage, or we may again revisit this because this is an important aspect of the embedded software testing. So this is one example. There could be several systems where those systems may not need a test software. Those systems by itself have been designed to support the target connecting with the PC without the need of test software. The next one is the manual testing, where the test procedures are tested manually. So previously we have seen automated test is done through the PC based application. In the next group of testing, we use it manual testing. So manual testing, The target board is tested manually. So, with the help of an IDE, integrated development environment such as Code Composer Studio or 3 These are some of the IDEs that are used specific to the processor. So, with the help of a watch window or debugger and any measuring equipment such as oscilloscope or digital multimeters, we will have a manual testing done. In addition to the automation test setup, we have the data is connected. We know that in automated testing, we don't have a debugger. We will use the target board as a black box. Here we will use it as a white box with the help of IDE. That IDE is hooked with the end target using a JTAG. So the JTAG is connected with the test box, which in turn connects to the evaluation board or the target board. I can say the target board. So rest of the end-to-end setup or connectivity software, test procedures are manually analyzed using code instruction or debugger execution. We can also do an automation on the debugger. The IDEs will support that actually. There are IDE commands. With the help of them, we can do an automation. We can do the batch execution on the debugger window. And the results are processed manually. It means the results are captured with the help of a logger or whatever it is, and the outputs are determined whether it's a pass or fail. The embedded software is updated same here also, like test function, test code will be there here also in the zone of use. And we can list out what are the test procedures which will be used for the manual testing. Next one is the picture depicting test environment. You can see here test environment. As I said, this desktop or a PC will have a testing tool, IDE or any of the automation tool based on applications such as VC, VB, etc. So that will have a connection with the target board. A target board can be fed with the real-time inputs with the help of a test panel or the breakout box. So with this, the test environment will be used. Okay. So here, few examples I have put. The structure is same basically. The automation test procedure. It is same as a manual test procedure. Here test setup will use automatic test setup, whereas in this case it will use the manual test setup. We know that in manual test setup we use IDEs or JTAG based debuggers and all that. In automated test setup we use a black box connectivity in the test system. Rest is all same. We can insert the script here, what we are talking here, so that we complete the particular test procedure. Similarly, for manual testing, we can also have the script based on the manual testing. So that is with this procedure we are talking about. And we use some of the environment specific preconditions. As I said, specific preconditions with specific values will be highlighted in the test procedure document. Those could be, for example, the different voltages, setting up these different voltages, and some of the unlocks, setting it to the values as 1.85, etc. So all this will be part of the preconditions that are required for specific test of specific group of tests. Here we have put the automatic test setup. What are the contents? Like this is Windows environment, application test software, MA card for CAN communication, power supply, execution tool for downloading the embedded software, and test box. The target board will have a target board, the crossbar, and certain panels for analog, discrete inputs, etc. So there could be a connection hook for oscilloscope. Typically, oscilloscope for multi-channel capturing, we use female connectors, such as BNC VM connectors. We can use them. For manual test setup, it will be similar to the one that we use for automatic test setup. Exception is being that there is a data. We use a IDE and the host side for manual test. Test will be almost same as the automatic test setup. So that is about test setup specification, how it is going to test setup, automatic test setup, how it looks like, manual test setup, how it looks like. Similarly, we can have test software build detail, tools information, like the tool version which we use. We know that test software build is something like a special build which is used for having the test software inside the candidate target. So this details will be tools version, its references, and any special instruction that needs to be taken care, etc. can be highlighted during the tools information. And some of the tools may require to be qualified. It's called tool qualification. Tools qualified data. All that have to be pointed out. Tools qualification in the sense, for example, in an aerospace project, they look for a stringent test process. They look for stringent guidelines as per the DO, suppose defense standard. So what they specify is the tools that are used for testing or developing the embedded software should have a qualified report. That means the tools have to be foolproof. I mean, tools should not generate an intermediate error. It should not be a buggy or a defect producing tool or defect producing instrument. So that needs to be as part of the tools information. Similarly, we have a software download procedure, as we said in the earlier section. Download instructions will be there, along with any of the operations on the target board needs to be specified. So this will be part of the test procedure. So likewise, we can have as many as the information, but all this have to be part of test procedure. That means we should not miss out anything that are related or relevant to the test procedure. Okay. So that is an example, just the example of a test procedure. So test procedure document will have identifying the test procedure, its organization, applicable external handling tool document, any other reference document. Then test procedure is based on which environment, the manual, automated, and how it's going to be executed. So what are the options for testing PC-based application or any manual testing done on the target code, etc. Then we have procedures for installing or using the automated testing or manual testing setup. In the end, we need to have a special information about all the tools or the build and all those things. That is about test procedure document. So, okay, so that is nothing but test case design and procedures in this session. Maybe we will continue this session about test case and procedure, with the last one being the test standard. This will touch base in the next class.